Series on data structures. In today's lecture series, we will discuss about shortest path algorithm called as Dijkstra'S algorithm. So before uh, before we get to start with the discussion of Dijkstra'S algorithm, let us discuss about the problem statement given. So here is the selfie two story of a person called as Kapi. He want to complete the tour of entire cities to celebrate the universal contest. So what he's doing is initially he plans the route. That is, he develop an efficient strategy to visit every places in the planet. Next, he visits all the planet and he takes selfie in every planet. So as he visit the planet, he meets the leaders in the planet so that his relationship is strengthened, and he also get to experience all the local foods and cultures in the planets that he is visiting. And as he visit, he captures his moments on the planet and share those moments on the social media. So once his tour is completed, he celebrates his universal contest. So before we discuss Dijkstra's algorithm, these are the topics we have discussed earlier. We have seen what is connected graph, what is undirected graph, what is spanning tree, and what is the weight associated with each edge mean. So these are the topics we have seen earlier. And what is the need for Dijkstra's algorithm is that it is mainly used for finding the shortest path. Uh, and in case of routing, network routing, it is used in finding the efficient path in network communication system. And in case of GPS navigation, it is used to calculate the optimal route for GPS navigation devices, and is also used in logistic, robotics, and many other applications. So Dijkstra's algorithm, it can be defined in these ways. It it has a designated single source node as a starting point of the algorithm. So initially, you will assign the distance 0 for from source for the source vertex, and infinity is assigned for all the other vertices. And you will identify the nodes as unvisited to begin exploration. So from that designated source node, you will calculate the distance to all the other vertices. So this is the working of Dijkstra's algorithm. That is, it computes the tentative distance to the neighbor nodes and it updates if it is smaller. So once the node is visited, it is marked and is removed from the unvisited set. And any unvisited node is chosen along with the smallest distance will be updated. So it checks if all the nodes are visited and check if there are no infinity distance for any of the vertices, which means the vertex is left unvisited. If that is the case, the algorithm is terminated. So here is an example for a Dijkstra's algorithm. So in the first step, except the source vertex, for all the other vertices, the distance is updated with infinity and 0 for source vertex. So the vertex here, 0, the vertex V0 has distance 0, which means it is chosen as the source vertex. Next, we identify the adjacent vertices of 0. Adjacent vertices of 0 are 1 and 2, and the distance is 4 and 8. To reach 1, it is 4, and to reach 2, it is 8. So when we compare with the previous distance in the table, 4 and 8 are minimum. So it is replaced. So for vertex 1, the distance is 4, and for vertex 2, the distance is 8. Now, vertex 1 has a minimum distance, so it is updated. I mean, it is visited. Adjacent vertex of 1 is 4, and the distance to reach 4 from 0 through 1 is 10. 4 plus 6, which is 10, which is updated in the table. Now, next vertex that has the minimum distance is 2. So, adjacent, it is visited, and adjacent vertex of 2 is 3. Now, the distance to reach 3 from 0 through 2 is 8 plus 2, which is 10. And again, it is updated in the table. Next, the vertices 3 and 4 are visited. So when we visit 3, adjacent vertex of 4, 3 is 4. So distance to reach 4 from 0 through 3 is 20. But the distance in the table is minimum, so it is not replaced. Adjacent vertex of last vertex to be visited is 4, and its adjacent vertex is 1 and 3, which is already visited. So the final distance in the table is the shortest path from source vertex to the destination vertex. So this is the working of Dijkstra'S algorithm. Here is another example for you to work, and you need to find the shortest path from the source vertex A to the destination F. So as you calculate the distance from the source to destination, you will find the shortest path from A to all the other remaining vertices as well. So we have seen an example situation, and we have seen what is Dijkstra'S algorithm, how does the Dijkstra'S algorithm works, and we have also seen few examples. So hope you understood the topic. We will discuss some other topic in the next lecture video. Uh, this is a summarization of what we have seen so far. So under graph theory foundation, we have seen connected and directed spanning tree and edge weight. So for calculating minimum spanning tree, we have two algorithm, one is Prim's and Kruskal, and we have seen the working of Dijkstra'S algorithm and its application. So it is used in GPS navigation, network routing, and many other applications like logistic, robotics, and so on. So we have seen the steps for calculating the shortest path as well. So these are some of the reference. In the next video, we will discuss about minimum spanning tree. Thanks for watching.